Hey, Jules, I'm recording this instead of typing it just because I'm driving. But first of all, Tokisha, it's on us. That is so awesome. Webster Hall, I've been to. It's been around since I was in high school and college. It's a phenomenal place. And that's the weekend. That's a Sunday. That weekend from like Thursday on to Sunday morning, I'm going to Charlottesville to be with the boys for hiking. And I'm going to try because I really would love to do it actually. And I can maybe see if Mama is cool with it, and I could head out from Charlottesville and then cross over to go to New York directly, just not get off in Philly, go to New York, go to this thing at 8 with Cesar and maybe his girlfriend and maybe some other people, whatever, get a group together, have a kick-ass time, and then either jet back late or first thing in the morning. I think that would be phenomenal if I could do it. Um, but it's going to be a little bit of a I'm going to have my stuff with me. I just have to figure out the best way to do it. But I may be able to do it, and if I could, I'll tell you all about it. So thank you for letting me know. And if you hear of other things, let me know. Second thing, I'm so happy you're looking at the sky and interested in it. It takes time. It takes being in an environment like you are, this is unique because you're seeing it every day. You can see the changes over time, over, week to week, how more of the sky shows up, or maybe 2 week by 2 week. So a couple things I'd say. So the you want to get oriented. So you want to find the Big Dipper, you want to find the North Star, and look up how to do it. It's the bottom three. And I know the bottom two stars of the bucket points four distance between those stars. That distance four in the direction water would spill that's spilling out of the bucket, and that's the North Star. It's Polaris. It's not very bright. It has no tint to it. It's just whitish, and everything rotates around there because that's above the North Pole, and the Earth is rotating in that axis. Um, that being said, you'll see by the course of the night how things come up from. They come up on the uh, they come up on the east and come down on the west. Obviously, like the sun. And it's interesting. If you want to see what you would normally see in the summer and you're in the winter time, you wait until later in the like 4 in the morning. You could see some of the summer stars that you would normally see in the summer months at that time. That you normally in the summer months you'd see those stars like at, let's say, 7 or 8, and then you see it now at 4 o'clock in the morning. It just means that more of the sky has shown itself. So that's kind of neat and how they change over time. My sense is that the first thing is get a sense for what that's about, the spinning, and try to get it in your head where it is, and make some orientation with, try to look from similar locations always, so you get a sense for exactly which way is north, get a sense for what time, what's by what tree, what constellation. The second thing is you want to identify the ecliptic. That's the plane or the line, imaginary line across the sky that the sun, the moon, and the planets travel on. It just happens to be that the plane that the Earth orbits the sun around is the same plane off by a little bit. I think it's off by 15 degrees, but don't quote me on it. As the plane that the moon, or 5 degrees, the moon orbits. So they're all on the same plane, and the planets. So in other words, the plates of the solar system, the plates of the of the Earth going around the sun, and the plate of the moon going around the Earth are all parallel with each other. So that means that when you're on the Earth, you see them in the same, more or less the same line. And the best way to do it is to be able to identify where the sun's setting in the west and use that as a point. Before it's totally dark, you can see more or less where the light is, and then try to identify either the moon, if it's up, or another planet. And then from there you can connect them and get the ecliptic to figure things out. In addition, there's another plane, the plane of the Milky Way. And the Milky Way is obviously, trillions of stars, right? That Milky Way also has a plane, obviously, and that plane is very similar to the plane of our solar system by chance. So the Milky Way travels along the ecliptic more or less also. More or less. It's off, but it's more or less. Actually, it's not that close. They're not that close to each other, I should say. I shouldn't say that. They're not that close to each other, but they're not completely at 90 degrees from each other. When you're looking at the plane of the Milky Way, what matters there is that you're looking into the disk of the Milky Way. You're actually looking into the center of the Milky Way because there's more density, obviously, of stars when you look into the center, and that density is lined up in a line across the sky. The places where you don't see it is looking out of the plane, either celestial north or celestial south from the plane of the Milky Way. So that's just basically what you're seeing when you see that. The third thing I'd say is that in terms of identifying the planets are, once you see them, you kind of recognize them. They have they change, their brightness changes, but not spectacularly. Saturn definitely has a reddish tint. Just think of The Martian. Think of John Wadney and the color of the clay, the sand that's in there, the Earth, the material of Mars. That color is exactly the color you'll see, barring any like atmospheric issues with clouds and stuff, or forest fires or whatever. It should have that color, so that'll help you to identify. It's a yellowish reddish tinge for Saturn. Venus is almost bluish white. Venus is obviously closer to the sun than Mars, and because it's closer to the sun, it tends to be, quote, the morning star. And basically what it means is that when the sun sets, Venus is usually close to it. When the sun rises in time, Venus is usually close to it. It's not always a hard, fast rule, but it tends to be up in the sky closer to the periods of the sunset or sunrise. And oftentimes more sunrise, I believe. So that's one aspect of it. So there's Venus, white, closer to the morning time, called a quote-unquote morning star. And then there's Mars, has an orange tint, and that could be any time. It could be up. And it, obviously Mars can be up during the daytime at a certain period of time for several months or even several weeks at least, where you don't see it at night at all for any of the planets. Mercury also, because obviously it's closer to the sun, it travels with the sun more. Mercury is pretty hard to see. I have seen it. I've seen it in the sky, but it's hard to see, but you can see it. And usually you have to be at a location where either you're high up or it's very flat, so you can see close to the horizon. So, because when the sun's up in the sky, obviously it's too bright for you to see a planet near it. But as the sun's setting, once it sets, sometimes it sets and Mercury follows it, and there's enough dimness that the light reflecting off Mercury shows itself. But that's a real find. I've only seen it once, and I saw it in Vista Road, right off of Newbold. So that's Mercury. And then finally there's Jupiter. And Jupiter is very bright. It's not as bright as Venus, and it has a little bit of a different tinge color, if you can imagine that. It's a little bit more like beigey color to it when you look at it with your naked eye. You should use your binocs and give yourself time to lie down on a chair or on the floor with a pillow or something, and look. When you find, in particular, any of these planets actually, when you find them, try to get out the binocs and try to really look at it. Sometimes, in particular with Jupiter, you can see that you feel like it never focuses well like the other planets do, but that one does, and it feels like it's almost like a streak of light. And in reality, what you're seeing is Jupiter with a very bright, and Jupiter has, I don't know how many moons. It has a lot of moons, but there's really 6 or 5 major ones: Calypso, Io, Europa, and I can't remember the other ones. But it's but they're in a plane. They also travel in a plane, and they look like a line of dots across it. And those lines change, hour to hour, day to day. So much so that Galileo at one point was thinking of making a clock that's based on the moons, so you can have a way to checking your clocks to see how accurate they are with the moons by the location where they were. So that's the situation with Jupiter. And those are kind of the lay of the land. As far as the constellations, there are tons of things that are little nuggets inside the constellations, like double stars. Double stars are really interesting in that they have, some double stars are associated with each other. They're within a gravitational pull of each other. Those are pretty rare. Other double stars are very, very far away from each other, but in our plane of view, they look like they're closer to each other. But the neat thing is that there are some stars that have a change in hue between one and the other, and it's a very clear indicator of a double star and the change in the color, so you can pick up colors between different stars. Stars do have different colors, especially in telescopes or binoculars. Binoculars, by and large, are a very, very good instrument, like the ones you have for looking at the stars. You have to let your eyes adjust. So you go out there and you try to go to a dark spot, if at all possible, and let your eyes adjust. A good technique is if you have bags of, this is what I would do when I was in high school. If I had bags of bread or any kind of like packaging, like plastic packaging for something in the cafeteria, and you can take a little piece and cut out a piece and slide it inside of a flashlight, then the light becomes red, what comes out of it only, and try to dim it as much as possible so that you don't lose. Red doesn't close your iris, so that's very helpful for that reason, um, so that you can see better. But that's kind of a fun thing. Now, as far as books, there are 3 books that I'm very, very happy to send to you. One is a star guide by a person named Pasachov. That's the one that I started with, and I had the same one for 15 years, and I have it. And that one, it has the planetary charts. So, in other words, you look it up in the planetary chart. You look up the day, the year, and it'll tell you which planets are up at a given moment, when they transit, when they get to their maximum height and their zenith, and then when they come down. So you like sunset and sunrise, and it can give you a sense of where it's going to be the highest, and you get a sense of where they are in the sky. Second thing I can do, and I'm very happy to do you, is send you a magazine of Sky and Telescope or Astronomy, either one of them. They have for this given month. Usually at latitude 40, which we're at latitude 44 here. The reality, it doesn't change a lot from latitude to latitude, and you can adjust for it slightly for the angulation, but it's such a small difference that it won't make that much difference in the sky. So that's the second option. The third would be, there's a book that I have that is about, it's called 365 Nights, and it's an old book, but it is phenomenal. It's all written out like someone wrote it out in a notebook, but it's an official book, and it has every night of the year a specific aspect of the sky that you could see at that night that's interesting, and it gives you some of the history, and it gives you there are some variable stars where you have 2 stars that are close to each other, and because they're close to each other, one of them changes in brightness over the course of weeks, sometimes days, and the other one doesn't. So you can appreciate day by day how they change in color from each other. So small changes in the way things look. I will print out and give you a list from your location of the ISS viewings, when they'll happen and when you'll see them in the sky. That's helpful. You may see Starlink, which I've never seen yet, where it's Starlink comes in as a string of lights that go across the sky. And you're high enough now, so the sun goes through a 7-year cycle and of sunspots. So we were in a nadir of sunspots about maybe like 3 years ago, maybe 2.5 years ago. And since then, we've been climbing to a max of sunspots. It's probably going to happen in a year and a half or so. And the reason why it's important for astronomy, because every sunspot is a reflection of activity of coronal, either mass coronal ejections from the surface of the sun, or these magnetic, basically a lot of highly charged ions leave the sun and travel like this wave of a sphere coming out of the sun, or really, it's not a sphere because it points in a certain direction. And that wave eventually takes about, it depends on the ions, it depends on their, light takes 8 minutes, I think it is, to come over, but it takes really sometimes several days to arrive at the Earth, these waves of ions. But the ions kind of come in as this like big wall of ions traveling away from the sun, and the Earth is there, and the wall kind of like splashes onto it. And the magnetic poles take those ions, and instead of the ions hitting us in the head and causing cancer, the magnetic poles take them and channel them into the North Pole. So they move so quickly into the North Pole Is it into the North Pole? Yeah, it's to the north from the south. So into the North Pole. That's the way I remember. I may be wrong. That you can imagine the magnetic field goes from the North Pole to the South Pole in this like kind of loops that go around the Earth. So when the ions, these highly charged ions, enter a magnetic field, they travel along the fields like a highway. And you can imagine if everything's going to the North Pole, the density of the ions gets higher and higher the closer you are to the North Pole. And right at the North Pole, you have all the captured ions traveling into the Earth at that moment. So the closer you are in higher you are in latitude, the more likely you are able to see aurora, what they call northern lights, aurora borealis. And um, and so when we are at a peak, which we're getting to, which you're very lucky, you may be able to see that. And that depends on when there's mass coronal ejections or increased activity. I keep track of the increased activity just because of the stuff that I get for ham radio. Increased activity is a it charges the high atmosphere, the ionosphere, and it makes signals that we send out from an antenna that has electromagnetic radiation coming up towards the sky bounce off the ionosphere better and then travel back in a triangle, going up in a triangle, bouncing off the ionosphere and coming back down onto the Earth, so you can get longer high frequency conversations. So that's really helpful. Ham radio people love when the sun is more active, there's more sunspots, which is coming up. So ham radio, the field is in the next 3 years are going to be very active, and then it kind of cools off and there's less, you can't make as many calls to overseas as easily in the times when you're in a nadir. Um, so auroras are another great thing to look for. And as far as, I mean, I think a good thing to do is to like work at learning the constellations so you get comfortable with where things are. There are um, in horoscope, there's what they call the zodiac signs. There's 12 of them. I think there's 12, 13, 12 zodiac signs. I think it is. And like Pisces, Capricorn, all that crap, all those different zodiac signs. Basically, they are every corner, every segment of the sky is broken down into these boxes where the different zodiac signs are, the constellations are. Like Leo has the constellation of Leo, but it has a very delineated box, like states, like Utah, that has a blocks around it. And anything inside of that is inside the constellation Leo, even though it's not inside technically the actual drawing of the Leo, it's inside the box that's around it. And the zodiac signs are the ones that travel along the ecliptic. That's why they stand out. There are many other constellations that are not zodiac signs, but the ones in the ecliptic tend to get a lot more kind of, news, because in horoscopes they talk about a particular planet being inside a certain sign or zodiac sign. And it just happens to be that planet in the sky. You could see it inside of Leo, that kind of thing. So that's kind of neat. But learning the constellations is pretty doable. I mean, I've learned them a bunch of times, literally, and then you forget them. You have to kind of like repeatedly do it. I did it with flashcards to learn the individual kind of shapes of the of the what's it called, of the constellations. But also, there's another book that's by the author who wrote the what's his name, the monkey and the man with the big hat, the yellow monkey, Ralph, no, George and the man with the big hat, the metal hat. That same person, that artist, took the constellations and drew them a tiny bit differently, but set up a system in one book that you learn what the constellations are. I recommend it, and I can bring that or send that to you. Just let me know what you want. I'm happy to send it to you. The last thing I'd say is that that the moon is another interesting one to look at. The moon is fascinating in its different phases, and at the penumbra that's between the shadow and the light, you can get a lot of details about how the moon is doing at different issues of craters and so forth, and name the craters. There is I think it's called the Man on the Moon, or there is there are some specific, I think it's called the Man in the Moon, where the the shadow creates like the image of a person in there. It's hard to see, but you won't be able to see it with Binox. I've never seen it, but it's just something cool to kind of look at and do. So that's basically it. I hope this helps. Just send me an email. Let me know what you think, and I'll send you this long message as an email. Sorry for the 20 minutes. Bye.